Hello everyone, my name is Li Zongyuan and my professor is Dr. Yang Chun Liang, and this is my final report in this class. Today I'm going to talk about what I am doing in our laboratory, and next I'm going to talk about what I'm going to do. In our laboratory, we are doing some research that connects with the NB-IoT, like NB-IoT communication, smart agriculture, and smart wearable devices. Here I'm going to talk about what is NB-IoT. The NB-IoT full name is Narrowband Internet of Things, and it is the LPWAN radio standard set by 3GPP, and it is single narrow frequency with limited bandwidth at 20,000 Hz. And NB-IoT is important connectivity technologies in the 5G era, and it will drive explosive growth in IoT devices over the next decade. And why NB-IoT? The NB-IoT advantage is simplicity, and it is an efficient IoT solution that significantly extends device battery life and has significant cost advantage for large-scale deployment of IoT devices. NB-IoT supports three operation modes: in-band operation, guard-band operation, and stand-alone operation. In-band operation: it uses one of the existing LTE carrier bands, and each band is about 180,000 Hz to 200,000 Hz. Guard band operation: it uses the band length between the LTE carriers, and this band between LTE carriers is to protect and avoid signal interference. In this picture, we can note that the NB-IoT is built on the LTE carriers and the GSM carriers. And here I'm going to talk about the NB-IoT key features. Optimized power consumption, also called low power consumption. It means it works on the low power, and if it's not working, it will enter to the standby time. High propagation, better coverage, also called high coverage. Compared with the existing LTE and GSM, NB-IoT enhanced by 20 dB gain, and its single transmission coverage is larger. And compared with some IoT devices, NB-IoT has a strong indoor coverage. High endpoint density, also called high connectivity. In the range of a base station, it can cover many sensors, and each sensor can support 50 to 100,000 connections. Low complexity devices, also called low cost. Compared with some IoT devices, the NB-IoT costs lower. Bidirectional communication. It means it can not only receive but also send the information. And usually, the bidirectional communication is also necessary in the IoT. Limit throughput. Usually, thousands of kbps, and it is related to distance. LTE level security, also called high security. Why is it called LTE level security? Because the MBLT is built on the LTE infrastructure, so it has the same level of security as LTE. For example, it will have certification and also have encryption. Global standard in licensed spectrum. It is set by 3GPP and it is globally versatile. Here I'm going to talk about the MBLT major markets like public utilities, logistics business, and consumer market like personal wearable devices. Smart city like smart parking lot, smart street lamp. Smart building like smart meter and smart water meter. Smart industry like smart medical and smart agriculture. In my research, my motivation is to reduce traffic accidents caused by fatigue driving and distraction. I will utilize Raspberry Pi 4 Model B development board with a MBLT development board like SIM7000C head and adapted voice recognition to detect the existing machine PapaGo to implement a real-time voice recognition for determining whether the driver is fatigued or distracted, and that the related person can receive instant messages and to reduce the traffic accident. In my research equipment introduction, I use the existing introduction PapaGo FW100. It has AI pupil recognition to detect whether the driver has fatigue driving or not paying attention with flight mode, and it also has GPS antenna. When the speed lower than 20 kilometers, it will stop detecting. In my research, here are some software and hardware I will use. Software, I will use Anaconda and CAN models in Keras. Hardware, I will use Raspberry Pi 4 Model B development board and MBLT development board like SIM7000C head. In my research, there are some outlook for the future. Since it is not only PapaGo FW100 that can be identified, I hope that some devices such as TPMS, the tire pressure monitoring system, that can be combined in the future. It can also be combined with facial recognition technology to achieve more accurate detection in order to reduce dangerous driving. And here are some reference sources of my research. Thanks for your listening.